Welcome to the next video from Firefighter TDC. Here we're going to talk a little bit about aerial rigging. This video is meant to be a little bit more of what to avoid and what you may choose to do to create a safer operation. I am by no means telling you to go out and use this on your aerial truck. It's going to depend heavily on your manufacturer, your department and what they allow, and your abilities and education as far as rope rigging and rescue. This topic was brought up through a few different discussions recently from members that are on different organizations, just regarding what is safe and what is unsafe. Excuse me. In this image, you see myself rigging an aerial truck and using it as an artificial high directional, or AHD. In this case, we knew what the load was, or the victim package. We had a decent angle of incline. We had a 1,000-pound tip load aerial apparatus. We knew our cylinder pressures on the master cylinder. So there's a lot of different things that go into this. This video was just meant to give you a few very small things to consider if your organization and your manufacturer allow you to use it for rigging. Again, I am not endorsing you to go outside of what a manufacturer's recommendations are in any way, shape, or form, but we're going to talk a little bit about this rigging. In this image, you can see we have the aerial straight off the tailboard, so we're coming as a straight on angle as we can. We've connected to 2 points on the bottom of the basket. Each of these points are rated at 500 pounds apiece, and we've brought them together in a sling configuration. One of the very careful things that we have to calculate is right here, and it's hard to see in this image, these are single pulleys on each side. There's one here and one here. And anytime you have this as a change of direction, and I pull down here and I have a load here, I'm not going to get into this. It's something that I definitely teach in person classes when it's easier to show than in a video. But this goes back to basic physics. What goes in must come out. So adding a pulley here, in effect, doubles the load I put on the basket. And there's things we can do to minimize this doubling effect. Some different rigging angles, for example. But just know that adding pulleys to the bottom of a basket is extremely dangerous, or has the potential to be extremely dangerous if you don't know how to look at what you're doing. I'm going to switch to a different image, and we're going to talk more about the rigging on the bottom of the basket. That's what I want to focus on this video, is if you were going to use it, what you may want to do. And before I go into that other image, I just want to say, if at all possible, adding any pulley system here is, I'll say, frowned upon unless you know your vehicle, know the limitations, know the load, etc. Best case would be to use a pre-made cradle, like on the top of some apparatus for a Stokes basket, or fastening a static line or a non-movable line, no pulleys, directly to the basket and using tag lines. A whole different thing. It has to be taught more in practical than through video, but a couple finer points in this video just to give you some things to either watch out for, or if you choose to do some rigging, some things that may help you in keeping safer. In this image, I can give you a better view of some of those watch out points that I was kind of mentioning. Here that we have a 500-pound anchor on the vehicle, 500-pound anchor on the vehicle. I know this basket is capable of a 1,000-pound tip load. When we rig this, if I were to rig this sling directly between those 2 points and then down to my central connection, which here I have a bear paw, if I were to rig this in a full triangle fashion with the sling, I put a lateral load against the 2 that are beneath the bucket. Doing so actually pulls them together and actually pulls them against the way the welds are created. So in this fashion, by using slings and bringing them both down to a central point, puts them more into a linear fashion of how they were welded to the vehicle and designed. With this, if I were to hook a single side and just hang the load off of one side, I'm creating a torsional effect on the ladder, and I'm putting one side or one beam into compression, and the other side actually ends up being in tension. which is exactly what we do not want to have occur with an aerial apparatus. If you've had aerial operator class, you learn that it's a truss construction. It's all meant to stay in compression. If we rest our aerial on a building, we're putting the thing into tension. It's the same concept with aerial loading, as if we put one side getting a heavier load than the other, we're twisting, we're putting a torsional load on the vehicle. So if your organization, if your training, if your aerial manufacturer allows you to rig the device for some sort of high point anchor or directional or static lifting, again, you're not supposed to lift like a crane with most companies, but if they do allow this and connecting directly to, take the ropes out of the equation, this will distribute the load more evenly to those two different connection points and equalize the load on the beams of the ladder. It's a much safer operation if you do use the aerial in this fashion. And again, I'm not saying you should, but this is something that you should consider if you choose to do so. Here you see a different type of aerial. We have a straight stick ladder instead of the aerial platform or ladder tower like we saw, or tower ladder. In this case, there are connection points here and here. The same concept applies. You have to know the rated tip load. To do this safely, you have to know the angle in which you're operating the vehicle, your master cylinder pressures and what they can safely be at. And the biggest thing is there's a fulcrum effect that takes place anytime you have an aerial extended out from the vehicle that we have to be cognizant of. Anything we do at the tip is going to apply more force down at the turntable because of simple physics. We have a fulcrum, we have a lever, and that creates a mechanical advantage. So some very safe rules. The closer into the vehicle we can keep it, so mostly retracted. The steeper the angle of incline for the aerial, the better. But then also, if we do choose to use these connection points, you should use them both and equalize that load between them so they both share the load. The angle in which the rigging, the bridle, the load straps, etc., the angle in which they come together has to be preferably less than 90 degrees to have, let's say, a 100-pound load hanging off the middle, and if it's less than 90, we'll have less than 100 pounds on each, depending on the angle. If we have 120 degrees, so we have a very steep angle between the two, if we have a 120-degree angle between the two, each one will see the full amount of the load. So it'll be a 100-pound load, could be 100 pounds on each side of that because it's pulling it torsionally inward, or laterally, excuse me. So the big things with aerial rigging, there's so much more to this than what I'm covering. This video is intended to give you some very small points to avoid a situation where very well-intended people could get you into a bind. These are very basic concepts that I also teach in aerial operators classes, not to teach the aerial operator how to rig up their truck, but to avoid having someone who's enthusiastic in rope rescue telling them how they're going to rig on somebody's aerial. So make sure, if this is something that your organization allows, your manufacturer of your apparatus allows, that you seek out competent training on your vehicle and how you're going to apply these principles and concepts. If you have any questions or concerns, please give me a call and make sure you get some reputable training on something to this nature. Thanks.